Algebra 2, Target 11. I can add, subtract, and multiply polynomial expressions. Today, the focus is on multiplying polynomials. To multiply, we are going to use what's called the box method. The box method is based on the fact that the area of a box is length times width. And you multiply the length times the width to find out how much is in the box. Well, if we line up one polynomial across the top and another polynomial down the side, and however many pieces, find each of the individual boxes and add them up, we can find the multiplication of the polynomials. So the box method is based on the area model of a rectangle. So let's use that. Multiply negative 2y squared plus 3y minus 6 by y minus 2. Right? So we're going to use the box. We've got a pre-drawn box here. There's 3 terms here and 2 terms here. So what we're going to do is we're going to take and make a 3 by 2 box. 3 for one polynomial and 2 for the other. So that would be negative 2y squared plus 3y minus 6 times y minus 2. And then we're going to find the area of each box. Area is length times width. So that's negative 2y cubed there when you multiply those. This box right here will be 3y squared. This box will be negative 6y. This box, negative 2 times negative 2y squared, that's 4y squared. This box here will be negative 6y. And this box will be 12. As we combine like terms, this is our only cube, so it'll be negative 2y cubed. Our squareds are here. We'll combine those. We get 7y squared. Our y's are here. We got negative 6y and negative 6y. That's negative 12y. And this is our only constant, plus 12. We've multiplied those 2 polynomials. The only difference from what we've done before is we just have a bigger box. When we did the 2 by 2s, the binomial did 2 by 2. We had 4 terms we ended up combining. Here we have 2 by 3. It's 6 terms. You may have a 3 by 3, 9. The only difference is you have a bigger box. Another example here. We got x plus 2 times 3x squared minus x minus 5. We're going to have 2 terms by 3 terms. It's going to be a 2 by 3 box. Doesn't matter if you draw it 2 by 3 or 3 by 2, as long as you keep the polynomial grouped together. So in other words, I could do this one like this, where I have x plus 2 down the side, 3x squared minus x minus 5 across the top, or I could do it like this, where I got 3x squared minus x minus 5 down the side, and x plus 2 on the top. Either way, you'll get the same answer. This box right here, x times 3x squared, we get 3x cubed. That ends up being this box here. This box here, negative x times x is negative x squared. This box here, negative 5 times x is negative 5x. Okay? The boxes are matching up. Down here, 2 times 3x squared gives us 6x squared. Right here, negative x times 2 is negative 2x. And right here, negative 5 times 2 is negative 10. Right? Those all match up. And then when we combine like terms, there's only one cubic, 3x cubed. Our squares are right here on this one. The same squares there. Right here, our linears give us negative 7x. Those again are the same linears there. And our constant right there is still negative 10. So it doesn't matter 2 by 3 or 3 by 2, you'll get the same answer. Number 4. All right, what do we do when we have three terms? It's not any different. You just do two at a time. Do those two, get an answer, right? So box a minus 5 and a plus 2. Doesn't matter what goes on the top and what goes on the side. A times a is a squared minus 5a plus 2a minus 10. When we combine like terms, we got a squared minus 3a minus 10. And then we're going to take this times a plus 6. So now we got a 3 by 2. And we'll have a squared minus 3a minus 10 and a plus 6. This box would be a cubed minus 3a squared minus 10a. Lower level will be 6a squared minus 18a minus 60. And when we combine like terms, we got a cubed plus 3a squared minus 28a minus 60. So that's multiplying polynomials. Sometimes you come up with patterns sometimes you can make shortcuts and avoid doing the box. One shortcut we've kind of talked about is the sum and difference pattern. You've also heard me say difference of squares. That's because our answer is a subtraction of squares. Those are the conjugate pairs where the middle boxes cancel out. Example, if we were to do this one, x plus 4, x minus 4. This is 4x, this is negative 4x. They cancel out. You just have to do x squared minus 16. All right? The square of a binomial we don't talk about too much. It seems to confuse you guys more often. But the gist of it is a plus b times a plus b is the same as a plus b squared. Here you got your a squared, here you got your b squared. These are both ab. We know they're going to be the same, so we just do double that for our shortcut. Now the cube, the shortcut here is actually kind of helpful because then you don't have to do like we did in this last problem, where you do two at a time, get an answer, and then do another one. For the cube, you can do that all the time, but the shortcut, you kind of put your numbers 1, 3, 3, 1 out there, and then you got your first term, it'll go a cube, and then you'll just power down. 3, 2, 1. And then when you get to the last term, it's gone. For the b, you do the same thing. You just start at the back and go backwards. 3, 2, 1, gone. For the sum of cubes, or for the cube of a binomial where they're added, it's going to be, all of them are going to be addition. For subtraction, you're just going to alternate signs. Positive, negative, positive, negative. If that confuses you, do a plus b times a plus b times a plus b. Do it two at a time. All right, let's start with an example. Find the product of xy minus 4 cubed. I'm going to use a shortcut. The shortcut, we're going to have 1, 3, 3, 1. We're going to take our xy. The first one is going to be cubed. Then it's going to be squared. And then it's going to be the first power, and then it's going to be gone. Our 4 is going to be cubed, and we're going to start from the back. 4 cubed. Going to be squared, working backwards. It's going to be the first power, and then it's going to be gone. And because this is a subtraction, we're going to alternate. Minus, plus, minus. And then we just need to kind of clean it up. Xy cubed is x cubed y cubed minus 3 times 4 is 12, x squared, y squared. 3, this is 4 squared is 16, 3 times 16 is 48, xy. And 4 cubed here is 64. And if you wanted to do the long way, xy minus 4 times xy minus 4 times xy minus 4, you would get the same thing. Box these two, get your answer, multiply it, box with that one as well. All right, so here's a kind of an application model. Allows below give average depth of a new well drilled and the cost per foot of drilling a well. T represents number of years since 1980. Write a model for the average total cost of drilling a new well. So if D is cost, or if D is depth and C is cost per foot, to find the total cost, we can take our depth times the cost per foot. So basically we're taking D times C. Here's D, here's C. This has 2 terms, this has 3 terms, so we're going to do a 2 by 3. Alright, so our 2 terms are 109T and 4010. Our 3 terms are 0.542 T squared, negative 7.16 T, and 79.4. Right? Go through and find the area of each box. 109 times 0.542 is 59.078. This will be T cubed. The next box, 109 times 7.16, 780.44. This will be T squared. 79.4 times 109 is 86, 54.6 T. And then go through, we'll do the bottom. 4010 times 0.542 is 2173.42. 4010, and this will be T squared. 4010 times 7.16 will be 28. 711.6, and this will be T. And finally, 4010 times 79.4. This will be huge, relatively speaking to the other numbers. 318,394. And last thing, combine like terms. Okay, so it'll be 59.078 T cubed plus 2173.42 plus 780.44 plus 2953.86 T squared. Add our linear terms, 28,711.6 plus 8654.6, 37,366.2 T plus our constant, 318,394. Okay, big numbers, but it's the same concept. You find the area of each box. So in conclusion, to multiply polynomials, we are going to use boxes length times width. We just make our big boxes bigger than they were when we had binomials.